Hi, we have started earlier in last lecture digital receiver. So in this case, in the digital receiver, a decision circuit is used to obtain how much is the output voltage level, and based on the decision, we can say that there will be a bit present 1 or a 0. Now we have a decision circuit, and decision circuit output voltage, if it is more than the threshold voltage, so it can be a 1 present, and if it is a below threshold voltage, then a pulse was not sent, means there is a 0. Now here we need to obtain that what will be the error occur in the receiver. Now how many number of pulses transmitted within a particular period of a time, and how many number of pulses, how many number of errors in the given period. So based on that we can find out a bit error rate. So here we are having probability of error saying that a voltage is less than the threshold when a 1 is sent. Means we have sent a 1, so that's why we need to get the output above the threshold voltage, but we are not getting the voltage above threshold voltage, that is below threshold voltage we are receiving. So that's why we can find out a probability of error here for the probability that output voltage is less than the threshold voltage when a 1 is sent, and probability that the output voltage is more than the threshold voltage when a 0 is sent. Means we are sending the 1, but we are receiving the voltage below threshold value. When we are sending the 0, but we are receiving the voltage above threshold value. Means 1 is sending, but receiver is saying it is 0. When we are saying 0 is sending, but we are receiving 1. So now that is a probability of error. So we can obtain that a probability of error. Here the figure shows a probability distributions for received logic 0 and 1 signal pulses, and their different widths of the two distributions, which causes by various signal distortion. This one here graph, here the threshold voltage level, this one VTH, and this one is about your 0 level. Below threshold voltage we can identify it is 0, above threshold voltage we can identify it is 1. But what happen in a receiver, because of that noise sources, even if we are sending the 1, we are getting the output voltage that is below threshold values, means we can say it is 0. And sometimes we are sending a 0, but we are getting the output above this threshold voltage, and that is a probability of error while sending 1 and retrying 0, while sending 0 and we are retrying 1. So that is a probability of error. So we need to find out a probability here while sending a 1 and a 0. Here we can say a threshold voltage, this one is about 1 level, this one is about the 0 level, and here the probability P1 of V is equal to what? Minus infinity to V, means it is a P1 of V means what? We are sending 1, but we are receiving the voltage below the given threshold voltage, means minus infinity to V, means V is a threshold voltage here. Probability that the equalizer output voltage is less than the given threshold voltage if 1 is transmitted. Now this one is a fact here. You can say that below threshold voltage we are receiving, because we are sending the 1, but here we are getting a value of voltage that is a below threshold voltage. And then this one is about a probability of 0. You can say that the probability that equalizer output voltage exceeds V, that is threshold voltage, if 0 is transmitted. So that's why V to infinity, V is threshold voltage to infinity, means this is V to infinity we say. Now, so that's why a P0 of V here. So probability that equalizer output voltage less or equal to output voltage is etc. Now this one we have a probability of, we can say 1, we are sending P of Y1, this one is the curve P of Y1. Okay, if we are receiving A1, okay, that is about a distributions of one level, and this is about a distributions of a 0 here. We send 1, we are getting the P of Y with respect to 1, P of Y with respect to 0. But what happened when we are sending the 0? Now this is a below threshold voltage. But okay, so this light, it is saying a below threshold voltage. But the case, sometimes what happen, we are receiving the voltage above this threshold voltage. And this one is a portion, we say that when we are sending the 0, but we are getting the output voltage above threshold voltage, that is your probability of a 0. And this one is the graph distributions of when we are sending the 1 voltage, but we are getting the output voltage below threshold voltage. So that's why we say that this one is a portion here. We are getting the voltage below threshold voltage, that is a probability of 1. So now we identify that here what will be the probability of error. Now the case is here Q1 and Q0 is used, that is a constant. When we are having the same voltage, in that case that value will be 1/2. Portion of zeros and 1 are equal, we say. So that's why we can say it is half. So probability of error, consider that it is a 0.5 value. So when we say that probability of 1 or the VTH is below, probability of 0 that is above here. So we are getting a probability of a error. So Q1, this one is 1 we are sending, and this one we are having, sorry, here we are having a 0. Okay, we can have a probability of 0. Now we can say that this one is about a probability of error when it transmits send a 0 and 1 respectively. So we say that for a given circuit, given data, we are saying that there is a receiving 1 or a 0. So that 1 and 0 means what? Because of is some noise sources present in a system, so we are not able to understand that what will be the 1 and a 0 set. So now why this happen? In an optical system, so there are the noise present, and noise is because of what? Signal distortions, that is dispersion, optical amplifier noise distortion, or there is some nonlinear effects in an amplifier. So that's why there will be a loss in an optical system, or we can say that from any noise present in a system, or we can have intersymbol interference at a receiver there. So means we say that a noise power for a particular logic level 0 is usually not the same as a logic 1. So noise power will be different for the logic 0 and a logic 1. And the factor we consider that the Q1 and Q0, these are nothing but the weighing factors, and that is used generally for the distributions of the data. We say equal distributions here. Okay, we are saying that is about equal distributions. Okay, so we can, that's why we are saying it is a V, that value is nothing but a 0.5. Now the simplest method to understand that what will be the probability of error. So for that purpose we can understand that a simple Gaussian approximation of a given output. So we consider that a sequence of optical input pulses, and that is present at the equalizer output voltage, and it has a Gaussian random variable. So that's why we are getting the output of that distributions of 1 and 0, and so that's why we are getting a output voltage in the form of a Gaussian noise statistics for a binary signal showing a variance around the on and off signal levels. On and off means what? There is a pulses of 1 and a 0. Means we are having the mean and variance of a Gaussian output for a 1 pulses are, we can have a on, we say that is about the B on, and sigma square on, that is the variance. For a 0 pulses, okay, we can say that 1 pulses we can have a B on and sigma on here. Okay, we can have a B on and a sigma on, and we can have for a 0 that is B off and a sigma off square, that is a variance. And this A, we say B on and a B off, they are nothing but a label for the 0 and 1. Now first consider that if we say a 0 pulse sent, means there is no pulse, okay, at the time of decoding, then probability of error in this given case is what? That is the probability that the noise will exceed that given threshold voltage. And we can identify by at a receiver there will be a 1 pulse sent. So that's why we say that here 0 pulse, there is no pulse sent, and we are getting the output with above the threshold voltage, and that is a mistake. Means we can understand that there will be a 1 or misunderstanding of a 1 and 0 there. So if that's why the probability of error for the 0, that the equalizer output voltage, it is below the expected value. If we can have ranges from the VTH to infinity, this we can have below that value, and the 0 means what? We are having that bit 0 sent, so that's why a probability of 0. Similarly, we can find out the probability of error when we are having a 1 is transmitted, but decoder detect that is a 0 because the output voltage is below that threshold voltage, and this probability of error occurs because of that output voltage below the threshold voltage. So that's why we are having P1 of VTH, and here we say that minus infinity to VTH, and we have the equation F1 of V and F0 of Y. Okay, F1 of V and F0 of Y, and that F is nothing but what? Okay, we can use a probability density function for the 0 and 1, and that probability density function is nothing but what? It is depending upon what will be the signal, what will be the noise variance, what will be the mean value, and if within a particular given period. So that's why we find out what will be the probability there. Then we can have a bit error rate. We can consider that probability of error occurs for a given particular period.